So we want to talk about real world applications of linear equations. So the first type we're going to talk about deals with two main parts. We're going to have a constant part and a variable part to this. Okay, so the constant part is going to be an amount that will not change as other values are changing. Okay, so something that is not going to change. The variable part is something that will be changing, so it will change typically as the number of items will change. So we typically see this listed as something like per. So often we'll see, right, dollars per hour. So thinking about how much you're getting paid. So we'll see the word item. So maybe it's $5 for an item. And that item might be something more specific, say $5 for a book. So if you buy one, it's $5. If you buy two, it changes, it's $10. So your variable part is going to be changing with respect to the number of items that you're buying or doing whatever with. We also say each a lot. So that is linked in with the item. So maybe we'll say $2 for each something, right? $2 for each candy bar. That better be a really good candy bar. Okay, so the typical setup of these problems takes your total equal to your variable part times x plus c. Okay, so we're going to talk about each of these pieces. The t is pretty self-explanatory. It's a total, right? So often a total amount of money is probably the most used total that we'll see, but it can be a couple other things as well. So V is going to be our variable part. Oop, that's not right. There we go, variable part. So this is the amount that's going to be changing. Well, this is the amount that's going to change your total, basically. So it's what we're going to be increasing or decreasing by, which is what I like to think of it. Increase or decrease. So if we're thinking about making, say, $9 per hour, that $9 is going to increase our total amount of money made if we work more hours, right? So we can think about it like that. The C here is going to be our constant. So maybe you get paid $200 per week at a flat rate, but you get bonuses like a commission if you're selling an item or something like that. So the constant would be a flat rate that's never going to change. You're getting that money no matter what. Whereas your variable part indicates what your total might change by. And then we want to talk about this X in here as well, because we didn't talk about it. This X is going to be your unknown in the problem. So it's going to be what the problem is asking you to find most of the time. So it's going to say, how many hours did you work? Or how many items did you purchase? And that is what your X is standing in place for, because you don't necessarily know. So let's try out one of these problems. A salesman makes $20,000 per year plus $2 per item. So we said that that's a key word to look out for. So he makes $2 per item that he sells for his company. Write an equation to model this and then find out how much money he makes for the year if he sells 14,550 items. Show all your work. Okay, so we want to first start by defining our variables. So I like to just define X typically, but we'll look at what is our total, our variable part, and what is our constant as well. Okay. So We're going to start with our constant. So this is a number that's never going to change. This is an amount that this guy is going to get no matter what he does. And that is this $20,000 per year. That's going to be our constant. So this salesman gets $20 every single year, no matter what he does. Now, we do have a per in there. That's sort of a sneaky per. It's not indicating that this is a variable part because it's not changing. He's getting that every year, no matter what. So in this problem, that's not our variable part. So that's our constant, 20,000. Okay, so he makes $2 per item. So this is going to be, this $2 is going to be our variable part here, because we're going to be applying that multiple times, right? He gets $2 if he sells one item. He gets $4 if he sells two items. He gets $6 if he sells three items, and so on and so forth. Okay. So let's see, a total. It doesn't really tell us a total because it's asking us to find it. So this is something that we do not know yet. We're actually going to be looking for it. But we can say what we're looking for. So we're looking for the total money made. All right, and then X, this is standing for whatever your variable part is getting multiplied. So we said it's $2 per item. So variable part is always multiplied by your X part, right? So this is number of items, whether you have 2 items, 3 items, 4 items, so on and so forth. And it gave us a specific number of items that we wanted to sell. Said we wanted to sell 14,550. Okay, so let's go ahead and put this into an equation format and go ahead and solve it. So we said our total equals our variable part 2 times X, which we're saying is 14,550, plus our constant, which was 20,000. All right, so this is saying he sold 14,550 items. He gets $2 for each of those items. That's why we're multiplying it by 2. And then he gets that flat rate of 20,000. So we're adding that on at the end. So you want to just go ahead and plug that in your calculator, and we'll get T equals 49,100. Okay. And we always want to go ahead and answer the question that's asked. How much money did he make? He made, putting units on it, $49,100 for the year. Okay, let's do one more. So we're going to set it up very similarly. Okay, so it's the same kind of problem. Kid goes into a store, needs to buy a gallon of milk for his mother. She gave him $10. The milk costs $3.25. He also wants to buy himself as many candy bars as he can. Candy bars are on sale for, we can say that as 59 cents or $0.59 each. Write an equation and solve to determine how many candy bars he can buy. Okay, so this is going to be another total equals variable part times X plus a constant. And we know that because we can see those different pieces in the problem. Okay, so we're going to have an X, a total, a variable part, and a constant. Okay, so looking through this problem, the mother gave him $10. He's never going to have any more than $10 in his pocket. That's the money he was given. That's the total amount of money he has. So he has $10 to work with here. Okay, milk's going to cost him $3.25. His mom doesn't want him to bring home multiple milks. She just asked for one. That's a constant value. He better come home with that milk. So we're going to say you better buy that milk. So he wants to buy himself candy bars. Candy bars are on sale for $0.59 each, right? Each candy bar. So we always said our variable part is multiplied by our unknown quantity X. So we don't know how many candy bars we have. So the variable part, that's our 0.59. And we want to go ahead and always write in, what are we finding? What is X? So that is the number of candy bars. Let's go ahead and set up this equation. So we know our total, it's 10. We know that variable part, 0.59. We don't know how many candy bars he bought, so we're going to leave that as X, right? All we know that it is 59 cents, however many we get of them, so we need to multiply that. And then we need to add on how much we spent on that milk, right? So we want this total on the right-hand side, right? We want that right-hand side to add up to either equal to 10 or less than 10, right? He can't spend more than he has. So let's solve this. We're going to subtract 3.25 from both sides. All right, we'll get 6.75 equals 0.59x, and we're going to divide both sides by 0.59. All right, and I've run out of space, so we're going to work up here. And we're going to get that about 11.44 equals x. Now, you cannot go up to a grocery store clerk and say, I want to buy 11.44 candy bars. It's not going to work. So we need to round this to a whole number. You just want to be careful when you're rounding in these problems. If we round up to 12, well, we can't do that. Let's see what happens when we round up to 12. So we have 0.59. Let's say we buy 12 candy bars plus 3.25. So take a moment. Try to put that in your calculator. 0.59 times 12 plus 3.25, right? Well, we get 10.33. We can't spend that much money. He only has a $10 bill in his pocket. We can't buy 12 candy bars. So that means we have to round down, and we can say he can buy 11 candy bars. He can buy 11 candy bars. Can't buy 12. And we said he wants to get as many, so we don't want to round down to 10, right? Don't cheat him out of a candy bar.